Number 6. Let me start from the beginning again. It says if sine of x plus y is equal to 3x plus 2y, find dy dx. We recognize the need for implicit because we see y's kind of all over the place. And also, we have to involve sine's derivative. Sine is cosine of u times u prime. We have to be careful that we don't try to distribute the sine through, right? This x plus y is inside the sine function. We can't distribute that through. Now, if it was sine of x times x plus y, that's a different story. Then we can do that. We can do x sine x plus y sine y. But if it's just sine of x plus y, okay, we're not able to just distribute that through. Sine is not a standalone term, so we can't do this. I mean, there is some indifference identity that can allow us to expand, but we're not going to be worried about that. So understand that this is kind of like a standalone expression, and we have to just work with it in this form. So we need to think of this entire parentheses as our u value. Okay. So since sine's derivative is cosine of u times u prime, we jump directly into our derivative. Sine of x plus y equals cosine of x plus y times u prime. So the derivative of x plus y, x becomes 1, and then y becomes 1 dy dx. 3x becomes 3, and 2y becomes 2 dy dx. Okay. Understand that these two parentheses, they look like they're just next to each other and that they're in the same location, but they're not. The x plus y is inside the cosine, but this 1 plus dy dx is outside the cosine. I want to solve for dy dx. I want to get this dy dx out from under the parentheses. So the way we can do that is we can distribute the cosine through. And once we distribute through, then we're going to have 4 individual movable terms, and then we can rearrange and solve for dy dx. Okay, so next step, I'll distribute the cosine through. Once I have my terms all separated, I can move things around. I want to get the dy dx terms together, so I can factor that dy dx out. Okay, factor dy dx out. Divide the parentheses over. Okay, any questions here? Okay, so whenever you're ready, let's go to page 11. This is quiz worksheet number 1. Everybody good here? Okay. So page 11. The key is on the back page, so I'll be working through most of the problems with you, but if you're working ahead, you can always look at the back page to kind of check your progress. I'm going to be putting this on a separate sheet of paper. I think the spacing may not be enough for each of the problems, so just to let you know, if you want to work these problems on separate sheets, feel free to do that. Okay. All right, so here's number 1. Oh, and then so the quiz, our quiz will be the Tuesday after we get back from break. So we're just going to be cycling through these types of problems, right? So just these trig derivative rules, product, quotient, chain, implicits, and the bottom, a little bit of particle motion, going from position to velocity to acceleration, particle motion types of problems that you guys saw on the previous test, and then finally, find the equation of tangent line. Okay, so those are the topics that we'll be kind of working through today, tomorrow, and then also Monday after our break. Okay. All right, number 1. All right, we want to find the derivative. To find the derivative, though, there's something deceptive about this type of a setup. What can we do to rewrite this problem to help us visually understand chain rule involved here? Yeah, let's put that 3 on the outside. If you don't do that, I just feel like the chances of making a mistake is higher. But if you can get to the right answer without doing it, I won't take off any points. It's just, I think it's beneficial for most of us to have to do this. So that's pi squared. So we're not changing anything. We're just making it visually easier to see how that exponent is impacting the problem. Okay, so hopefully we see the need for chain rule here. Derivative rules that we have to be aware of here. The derivative of cosine of u is negative sine of u times u prime. Okay, so there's chain rule here. So there's 3 different layers we have to account for. There's the outside, there's the inside, and then there's the innermost. Okay, what represents the outside? Bracket q. Inside is just the cosine. Let's just do cosine parentheses. And finally, the innermost portion is that pi x squared. All right, we'll start with the outside portion. Y prime equals. What's first? Outside's derivative is. Drag the original portion in. I'll check that off. I took care of outside's derivative. Next up, in a separate space, I need to take care of inside's derivative. Cosine becomes negative sine of parentheses. Drag in the pi x squared. Took care of the middle portion. And finally, the innermost portion becomes times 2 pi x. So either you can pull it from this inner portion, part that I've identified, Or if you're just in the middle of your cosine rule and you understand there's a u prime involved, you can also do it as part of u prime. Okay, just don't do it twice. It's just either you pull it from here or you're pulling it from that negative sine u times u prime. Okay, there's our derivative. We're gonna do a little bit of cleanup, but any questions so far? Okay, I'm gonna do some cleanup in the sense that I can kind of push things to the front. I have the 3 here, I have a -1, I have and 2 pi x. So 3 times -1 times 2 pi x, I can push all that together to be -6 pi x. You can leave that squared outside the bracket, or you can put it in a more compact form, put that squared here as a shorthand form here. Either way. Okay, any questions here? I'm thinking of this negative as a -1. So the -1 is just everything's being multiplied. So I want to just, ideally, I want to pull that. This is not a minus sign. This is just a times -1. So I just find it easier to just a little bit cleaner to have that negative outside. But it wouldn't be wrong if you left it inside here. Yeah.
If we mess up the cleanup, are you gonna dock points on the equation test?
Depends. At most, it's be very minimal.
Okay. All right,
yeah.
So as long as we get the outside indicator, we'll get like most of the.
Yeah. This is the most important step. If you get to this part, you've earned most of the points, if not all. I'll be looking at. I mean, yeah. Yes.
So you always want us moving from like kind of like where everything's kind of organized to try to combine as many lectures.
Yeah, as much as possible. I know there are times when it's just like there's not a whole lot of things that you can do because of the messiness involved, but we just want to try our best. Because, if this is on the AP exam, multiple choice, your answer choice will look more like this than this, right? So I do want us to know how to rearrange and get it into a compact form to be able to match with future AP exam problems.
Yeah.
Okay, so I do want to point something out here. These types of problems do invite consistently, potentially missed kind of ways of missing problems. So I just want to point out some common mistakes that I see in the hopes that you'll be able to recognize them and be able to avoid them. So here's the common mistake number 1 that I see for this type of problem. The first is, if you don't put that exponent outside, then the tendency is, this is what I see. The tendency is students understand that there's a power rule going on. So they do power rule, they know that there's a derivative here, but then they forget that cosine is also being impacted. So this is what I see. I see students do this. They say y prime equals, they see that 3 there, they know there's a 3 cosine squared, so they say 3 cosine squared, and then they feel like they've taken care of that cosine's derivative, so then they move into the pi x squared, and they say times 2 pi x. So I think that's the danger. If you don't see that bracket cubed, it's easy to miss out on the fact that, oh wait, there should be a sign in my derivative. Okay, so just want to be careful with that that type of approach to the problem. Here's a second common mistake. Is where you do put the brackets in place, and you do, or I see students understand that there are 3 different layers involved, which is good, but the tendency potentially is that you want to kind of streamline your answer, and you want to put all the derivatives compact inside one another because it just looks cleaner. So I see this happen. Y prime equals, they see the bracket cubed, so they do the derivative, which is fine. But then they say, well, I'm moving on to my inside function. Cosine's derivative is negative sine, and it's inside, so I should put it on the inside. So they say negative sine of u. Okay, I'm ready for my inside derivative, and then they say pi x squared becomes 2 pi x. Okay, it looks nice and streamlined. You are taking each derivative, but this is not correct, right? We have to put them all outside of each other. We have to follow chain rule correctly. So careful with that mistake, right? I know that logically it feels right, but this is not the correct way of approaching chain rule. Okay. Questions? You guys okay with that? All right, let's look at number 2. Y equals. Okay, find y prime of 0. Okay, so this two-step process, I need to find y prime of x, and then I need to find y prime of 0. So two-step process, find the derivative first, and then we'll evaluate the derivative at a point. So what's involved here if I want to find the derivative first? Quotient rule. Okay. And a little bit of chain rule because of u prime there. Okay, f prime g minus f g prime. Let me remind us of the derivative rules that we'll be using. Sine of u becomes cosine of u times u prime. And cosine of u becomes negative sine of u times u prime. Okay, quotient rule. All right, f prime. Sine of pi x becomes times pi, right? Pi is pi x's derivative. G function. Back to f. Okay, g prime. Cosine of u becomes negative sine of u times u prime. What's u prime going to be? Just 2 pi. All over denominator squared. All right, so now that we have our derivative, I would say let's not worry about cleaning this up because it's not really asking for the derivative function. It's asking for the slope at 0. So I would just go ahead and start inserting all the x's with 0, and it will just kind of accelerate our cleanup process down to a number, right? All we care about is a number here. We don't have to worry about, because if we spend the time to clean this up, I mean, it'll just take longer, and we don't have to have a cleaned up version of the derivative. Just something that we can start inserting 0 with. Okay, replace every x with 0. All right, looking at unit circle. What's cosine of 0? Remember, 0 is not the ratio. 0 is the radian measure. What's cosine of 0 going to be? 1. It's the x value, right? What's sine of 0? 0. Sine of 0 is 0, so that's just going to wipe out all this. So I'm just left with pi over 1, which is just pi. All right, are we okay with number 2? Okay, take a look at number 3. Okay, no questions with 2, you guys okay? Number 3. Sine x over 3 cosine of y equals 2x. Find the derivative. All right, look at how this problem is set up. If I want to find the derivative, what process do you see us having to involve? Implicit, you got y kind of mixed into the equation and quotient rule. Okay. Quotient rule, f prime g minus f g prime. And the right side is just standalone power rule, right? Do the left side first. Okay. F prime g minus f g prime. Okay, one thing at a time. Sin x becomes, oh, let me write the rules that you'll be using. Okay, sin x becomes cosine x. G function. Back to f. G prime. 3 cosine of y becomes what? Good. This is where dy dx is going to pop up, right? There's that implicit. There's only one y in the equation, so that's where the dy dx is going to pop up at the g prime. All over the denominator squared, so I'm going to square the entire denominator, which means the 3 is squared, the cosine is squared, so I get 9 cosine squared y. Everybody okay with that? I'm just squaring both parts of my denominator. All right, so all this is for the left side. The right side is just becomes what? 2x becomes just 2. If I put it over 1, I can see that, okay, I can quickly do cross product, kind of get rid of all my denominator, and then begin rearranging and trying to solve for dy dx. So I'm going to pair my diagonals together, set them equal to each other. Two times 9 is 18. It's only one dy dx term. I'm just going to keep this on the left, subtract 3 cosine x cosine y over, and then divide out, isolating that dy dx. Final step, let's divide the 3 sine x sine y over. Well, we can do a little bit of cleanup after this, but at least we can move towards isolating that dy dx. You can factor out a 3 here. And now that the 3 is factored out, these I can remove the 3's, cancel out the 3's, and there's my answer. Can't cancel anything else out, right? Because things are being attached towards the sign with a plus or minus sign as far as we can go here. Okay, any questions with 3? We're going to skip number 4 and let's go to number 5. So number 5, it says, if velocity of a particle is v of t, find acceleration. So to find acceleration, we have to find the derivative. And also, what do you see being involved here if we want to find the derivative? Product rule. Good. Yes. Okay. The key's on the back page as well, so you can always refer to that. Yeah. All right, here's number 5. Go ahead and try number 5. I will walk through the problem in a little bit, but I want you guys to try it on your own. But you mentioned product rule, so we're going to take care of that. Reminder, sine and tangents derivative are there next to my problem. Okay, try that. Go through product rule, get to acceleration, and once you get to acceleration, then part B is evaluating acceleration at pi. So you can insert replace all the t values with pi and work your way down to a numeric value for acceleration. Okay, try that. Again, keys on the back, you can kind of check your progress to see how you're coming along, but I'll walk through the problem with you as well. Now you can use sine by 0. 0 as well. Take a secant as 1 over cosine. Yeah. Oh, no. Okay, let me walk through number 5. F prime g plus f g prime, sine of u becomes cosine of u times g prime. We keep the tangent, back to f, and then g prime. Tangent's derivative is secant squared of u times u prime. So secant squared of t times 1. I left off the 1. I just knew that it wasn't going to make an impact. So that's part A for finding acceleration. Next part, replace every t with pi. So we get cosine of 2 pi, tangent of pi, sine of 2 pi, secant squared of pi. Okay, think about where these are on your unit circle. Cosine of 2 pi is going to be 1, right? Cosine is the x value. Tangent of pi Tangent is y over x. 0 over -1 is 0. Sine of 2 pi, sine is the y value, which is 0. Secant is 1 over cosine. So think of cosine of pi. You know cosine of pi is -1. -1 squared is 1. Really not going to make an impact here because 0 is going to wipe that out. So I have 0 plus 0, which is 0. Yeah, it's good for you guys to reveal your unit circle values.
Isn't the cosine of 2 pi 0?
Cosine of 2 pi is actually going to be 1. It's
Yeah.
x value, right? All right, any questions with 5? Yeah.
Is there like anything you can remember the unit, or you're just like,
Yeah, maybe I can spend tomorrow kind of reviewing unit circle with you. Yeah, maybe we can do that. Because I feel like if you know what the first quadrant is, then everything else is just repeated, right? But I can run through something to help you refresh your memory on unit circle. All right, let's try number 6. So number 6 says find the equation of the tangent line of x equals pi over 4 for y is equal to tangent cubed of x. So let's talk about this problem for a moment. Okay, so here's our equation y equals 2 tangent cubed of x at x equals pi over 4. Tangent line means I have to find order pair, I have to find slope, and then point slope form. Your order pair comes from the original function. Your slope comes from the derivative evaluated at your x value. So let's talk about this equation here. Again, there's that deceptive exponent there. How can we rewrite it to help us see things a little bit clearer? Yeah, go on the outside. Now, as it goes on the outside, it's only going to go on the outside of tangent. The 2 is still not impacted by that exponent. So start there, right? There's a chain rule going on. Outside's derivative times inside's derivative. As a reminder, tangent's derivative is secant squared. So start there. You can find the derivative from there. Circle back to the original equation. Get your order pair, get your y value, get your slope, and then point slope form. Check the back for your progress, and then we'll go over it. Okay, let me go over number 6. Outside's derivative, 2 bracket cubed becomes 6 bracket squared. Tangent's derivative becomes secant squared. There's our derivative. I'm going to circle back to the original function to get to my y value. I'll insert pi over 4 in for x. Sorry, in for t. Is it x or t? X. Okay. Tangent of pi over 4 is 1. 1 cubed is 1. 1 times 2 is 2. There's my ordered pair, pi over 4, 2. To get to my derivative, to evaluate my derivative, I think it's helpful to rewrite that secant squared x as secant x squared, so that you kind of have a reference point that we really want to be finding out our trig value before we are squaring it or raising it to a power. So tangent of pi over 4 is 1, secant of pi over 4. Think of secant of pi over 4 as the reciprocal of cosine. You know cosine of pi over 4 is root 2 over 2. Flip that, we get 2 over root 2. Square that, we get 2, or 4 over 2, which is 2. 2 times 6 is 12, and there's our slope. Once we're there, point slope form, tangent line equation. Yeah, no calculus. We gotta know our unit circle values. Right. Yeah, same on the AP exam. We need to know our unit circle values. But I'll do a full review over unit circle. Maybe that'll be helpful for you guys tomorrow. Okay. Can we just start number 1 on page 13? It's a chain rule problem. Guys, as a reminder, this looks messy here, but how would you rewrite square root of x cubed? X to the what? Same idea here, right? This is square root of cosecant raised to the 3rd power. I can take this value and raise it to 3/2. It's just a messier, quote-unquote, variable, right? But it's the same process. Okay. Once you can get that outside a set of brackets, then chain rule, right? You got the brackets, you got the cosecant, and you got the inside parentheses. Okay. We take outside's derivative using power rule. Cosecant's derivative is negative cosecant cotangent. And finally, inner function's derivative is going to be -5. Okay, we'll continue with this tomorrow. I also want to review trig derivatives with you. Homework tonight from your textbook. This is basically what your quiz is going to look like. We'll have tomorrow to do a full practice, Monday after break, and then quiz on Tuesday. Okay. All right. Okay. All right. Okay. Thank you.
Yeah.
Wait, hold on a second.
I do on the